Masa tu post tu looking after all the research and technology developments in UTP dan several projects under Petronas. I've been relieved from the directorship post start 31st August 2021. So baru je lah Merdeka Day. So Merdeka from the post. So now back to the department as a lecturer. So this semester I'll be teaching on the static subject. So you need to bear with me, give some slack sikit to me. Because I've never been teaching online. Kalau masuk meeting online je, so I've never been teaching online. So you need to give me some slack sikit lah. I know it's hard for you guys, for me and for you guys to cope with the online teaching. But at least you dah experience this for some semesters. I'm not. So, okay. Kalau my rule of engagement for the class, I don't care about attendance. To be honest with you, it's not my responsibility to check who's come, who's not in my class. So it's up to you. You not join the class, you not join the class. That you are big enough. I respect you, so I'll treat you as adult learners. So I know some of you guys are the maybe more important things to do, but then you are definitely can catch up. Sebab I macam tu masa I belajar. So I know my own capability. I know how to catch up. I'm not really coming to the class. Tapi benda yang tak elok tu janganlah ikut. So I'm not really coming to the class, but I'll catch up for the subject contents. So again, I'm not care about too much about attendance. I mean, not care. I mean, I'm as long as you perform, as long as you are. Nanti kita akan ada several quizzes. We have a test. As long as you are performing, I don't mind. But if you are not performing, then ask the detail lah. Who's not coming? Who's not coming? Who's not submitting the assignment or whatnot? As long as you are perform. Okay, I close one eyes and then move on to our life. That's my start. Secondly, just to warn you, this subject you are first semester, you are second semester first year student. This subject is the beginning of the difficult courses to come. Okay, ini baru static. You are along the way too, you have dynamics, you have mechanism, you have solid mechanics. So all those subjects, what we call mechanics of materials in the subject, is to some extent to the people is difficult. Sorry, to some extent to most of the people or the student is difficult. Same goes. Same to us as well. Masa saya belajar kat USM, I first degree in USM, master in Leeds, PhD in Leeds. So, benda ni, this subject is to most of the people is difficult. So involve mathematics. Siapa yang enjoy mathematics, you will like this subject very much. But then somehow there will be people fail in the subject. So. It's not warn you, but I just give you the facts and the numbers. Some about 5 to 10% will fail the subject. So it's difficult subject. So if you don't want to be part of the statistic, then study from now. So you cannot study from us. Yeah, I mean. Kalau boleh, startlah something like maybe like 1 hour or 2 hours per day, just to looking at this lecture notes, and then some maybe 1 or 2 question weeks on this subject matter. Alright. Okay, before we start, Before we start, so I'll go to this one. Okay. This is MEB 1043. So as I mentioned before, after this, you will see more subject like this: dynamic, solid mechanics, fluid mechanics. Okay, so it involve the calculation on the applied mechanics, applied loadings, whatnot, resultant forces, moment. So there's no lab for this subject. So mostly assignment, quizzes, standard assignment, exam, answering the question here and there. All right, on the course content, chapter 1 is easy peasy, just a basic introduction to what you have been experienced before, forces and moment, system of units. This is mostly physics, STEM. Okay. Jadi kalau you ada difficulty to hearing me or whatnot, just give me a shout ataupun message ke whatever, atau just. And then we have this chapter 2, force and vectors. And then chapter 3, equilibrium of particle, free body diagram, equilibrium, whatnot. So chapter 4, force system resultants, moment, scala, cross product, whatnot. Chapter 5. Chapter 5, equilibrium of rigid body. Chapter 6, structural analysis. Banyak ni chapter. Chapter 7, internal forces. Chapter 8, friction. Chapter 9, center of gravity centroid. Chapter 10, moment of inertia. Okay. 12 weeks data. I mean, this is supposedly for 14 weeks. But 12 weeks, they're still not revising the content. So, ridiculous. Anyhow, apa? Kita tengok mana yang sempat. Don't worry. We may not cover until composite body lah. I think basic moment of inertia, but you'll go through this again in solid mechanics. Most likely composite body is just a very basics, but yeah, we'll see how it's going. This is our subject. Okay. The Bible of this course is Hibbeler. So this is what we'll be using a lot. Hibbeler making these books, Mechanics of Engineer. Get a copy if you want. A lot of questions coming, or example coming from this book, Hibbeler. Beer is not much been using for the, adalah reference 1 or 2 questions. But beer books is not user friendly. Hibbeler is user friendly. So really recommend that you using Hibbeler. Okay. Any question? Other question? You can just pop in the question in the message if you want. Similar doktor, tak ada rasa.
Tentang tutorial group kita, saya akan announce dalam 2-3 minggu akan datang ke? Ke bila?
Tutorial lah. You know about, kalau online, I don't care about online. Online you can fit in as much as people can possible. Not issue. Interaction online kan. How do you want to do that? You want to split into the conventional groups, or do you want, or meaning that you have, kalau timetable tak silap saya ada berapa? 3 slot. Tuesday morning, Thursday tak silap ada satu, and then maybe Tuesday afternoon tak silap. So how are you gonna do that? Do you want to to cram everybody in one slot. Maybe we go about 2 hours, and then I can do it myself if you want, or you want to split into the separate group. But most likely GA will handle that. Ketua kelas tadi, siapa nama? What's your name? Yang selalu hantar nasi. I know. Yang Yan Wei.
Yes.
I can call you ketua kelas lah.
Okay.
You're very good on this. Yes, all in one is more preferable.
Yep,
Right, feedback?
all in one, I guess. I don't think anyone objects to this, right?
Yeah, I think we don't make this complicated lah, kan? Save people times, and then all can directly engage with you, rather than giving the GA. Sometimes I'm not really that particularly keen of GA taking the tutorial. Sometimes they just dia tak ada communication tu. Any one object, just post in the okay, any one object, just raise your hand. Anyone yang object. 1, 2, 3. Tak ada So we'll do one maybe about 2 hours, 2.5 hours, something like that, and then we work out the detail together. Yan Wei, tolong I satu, get the preferable slot. I don't mind kalau you nak buat malam 8:30 to 10:30, I don't mind. I work until night, so I don't mind.
Okay, the slot duration berapa lama lagi?
Slot duration, let's say kita start during weekdays, okay. Not morning. Not too morning lah, not too morning.
Okay.
Morning ni kita jogging dulu, kita exercise dulu, jaga kesihatan. Not that too morning. Maybe 10 ke atas, 10 pagi ke atas sampai 10 malam. That's my duration. 10 pagi to 10 malam. Up to you.
Okay, so I
Only have this one subject. So you fit the time slot, I will most likely follow the time slot. Kalau I tak dapat, I bagi you tahu in advance.
Okay.
Okay lah? So senang macam tu lah. Okay. Okay. I'll usually share my handphone address to the student. Any very urgent matter you nak contact, you boleh contact. Tapi I won't save your number. You kenalkan Adri, I'm your student, blah blah blah. What's the issue? Okay, tak masuk kelas ke apa ke? Just let me know. I'm a very reasonable person. This is my number, email, address. Hari ni you nak belajar serius ke you nak belajar relax dulu baru introductory, get to know each other, ke you nak belajar terus?
Saya rasa belajar terus, boleh, baik.
Bagus lah. Alright. Okay, kita belajar terus. If you want. Relax juga. Tak apalah, kita start introductory, and then what are expected from this. Okay, so this is the very, very basic one, chapter 1. Okay, just to give you a reflection ataupun some refreshment on what we're going through. Okay, so first, this is the bottom one, Newton's law of motion. So kita ada 3. First law, second law, and third law. Okay, ni you belajar masa fizik ni SPM. So not that big issue. Nampak Boleh Dapat macam ni? Can you see clearly?
Oh yeah, we can see.
SI system of unit, of course, kita tak guna imperial, kita guna SI unit. So SI unit, something like meter for length, kilogram, kilometer, whatnot. So this is where you need to go like, what is a milli 10 minus 3, what is a micron, 10 to minus 6. All this you need to know lah. What is milli stand for, what is micron stand for. What is mega stand for, 6 giga. So all these are basically that we are using for the system of units. And then examining the standard procedure of perform numerical calculation, and then present a general guide of solving problem. So mostly we are talking about vectors, scalar, how to resolve that into x, to y axis, how we're gonna do that, the what we call the equilibrium equation, because we are talking about static. So you can remember static, not dynamic. So static F equal to ma equal to 0. So that is the basics, always equal to 0, always or equilibrium. Okay. So what is mechanics? So mechanic is basically we are talking about body. So body ni is usually two. So one we consider as a rigid body, another one we consider as deformable body. So ada dua benda yang akan tengok when we talking about body, rigid and deformable. And then we have forces applied to it. So forces ni can be a mechanical forces, mechanical loads. Contoh mechanical loads ni we are talking about applied load. So applied load ni can be from the external, macam ni api ni. So external can be weight of the people on it, weight of the structure on it. Can be ni thrust force. This is thrust force from the combustion of the rocket, right? It can be a reaction force. This is a reaction force, what we call reaction force, right? So this is third law of Newton. It's a reaction force. So this is applied force. Lagi apa? It can be from the structure, part loading, whatnot. Apa? Long way tu nanti kita akan go through detail. Alright, branches of mechanics. Macam I cakap tadi So this is one, rigid body. So this is deformable bodies. And then another one, yes, fluid. Okay, so fluid ni I tak cover sangat. So it's more on the fluid mechanics, whatnot. So subject tu I tak expert. So I tak reti sangat. So these two things. Right, so we are talking about rigid body and we're talking about deformable body. So ini kita punya subject semester, static. Static meaning that equilibrium. Dia tak bergerak. Contoh jambatan, a bridge. So what happen if the bridge in the dynamics? So there's a lot of the excitations, wobble. That is when there's no longer equilibrium, then there will go dynamics. Okay. So dynamics ni bila F equal to MA, A ni ada value. A is not equal to 0. So ada acceleration kat situ. So it is dynamic. Kalau A equal to 0, which is ada velocity, dia bergerak, tapi dia tak ada acceleration, is constant velocity, then A is 0, so hence F ni still 0, then it is equilibrium. Okay. Deform body ni you akan belajar. Yeah.
Sorry to interrupt, but did you forget to record the class?
Kena record sorry. Record and then kena letak dekat mana? Sorry I'm novice dalam online teaching. Tak maaf.
Oh yeah, just tekan start recording there. Yeah.
Selalunya bila meeting, bila jadi boss, jadi director, my staff jangan tekan recording. Okay, so betul ada record Alright, good. Thank you. Okay. Solid mechanics. Solid mechanics ni kita akan belajar pasal deformability. So things that do change shape. So dekat sini is more on the material model itself. So dia ada materials undergoes the plastic deformation, meaning that it's change shape. It's a irreversible changing in term of the shape. So tapi dekat static ni kita mostly tengok on the is elastic. Dan no, it's not even elastic. Elastic kat sini juga. Ini we don't consider that change shape at all. Very basic. But when you're talking about subject dalam solid mechanics, we can involve changing in the shape of the structure itself. So kita akan tengok elastic, plastic, failure. Yeah. So this is some of the things that we're looking on the solid mechanics. Next. Okay, ini semua yang cerita tadi. So it's all been putting nicely in words. But all are been there. So kalau static at rest dan juga constant velocity. Constant velocity still A equal to 0. Bila ada accelerated motion, A is not equal to 0. Hence total F equal to MA. So basically inilah yang kita tahu, whether that's this is part of the criteria that consider whether it is static or dynamic. Okay, so mostly kita akan pakai ini. Okay, so this is what happen if what is static is not applied properly. Tak berkejap lagi ada satu YouTube video. Ada orang share kat I. So what is the why we need to learn this? Why we need to appreciate the static condition? So if the static condition is not applied properly, this will happen the truck ni dia fall down backward. So it's not equilibrium, statically equilibrium. So this is what happen Okay. Before we go to this one, kita share dulu some basic awet. Tak dengar. Speaker.
Statics, the study of how objects behave when they're not accelerating, whether that means they're standing completely still or moving at a constant velocity. Statics can tell you a lot about the way things behave when you're trying to balance them or when they're being compressed or stretched. So engineers use statics for things like figuring out where to put building supports and how many of them there should be, or what type of bridge design will work best to cross that river in town. You can use it too. Say the next time you climb a ladder. If you do, you'll find that even though an object may not be moving, there are still all kinds of things affecting it, like stress and strain and pressure. So who knows? Today's episode may someday save your life. Objects that aren't accelerating are said to be in equilibrium, a concept that we've touched on before. It means that there can be forces on an object, but there can't be net forces on it. Otherwise, that net force M would make the object accelerate. Torque affects equilibrium too, since an object in equilibrium can't have rotational acceleration either. So again, there can be torques on an object in equilibrium, but there can't be net torques on it. In other words, the net torques must be equal to 0. All of this means that for an object to be in equilibrium, all of the forces and torques on it have to balance out. A classic example of forces and torques cancelling each other out is a ladder leaning against a wall. The ladder isn't accelerating or even moving, so it must be in equilibrium. But how much force is there on the ladder from both the wall and the floor? That's pretty easy to figure out. Let's say we know the bottom of the ladder is 3 meters from the wall and the top of the ladder is 4 meters from the floor. The ladder itself is 5 meters long and it has a mass of 10 kilograms. The first thing we've got to do is draw a free body diagram. First, the force of gravity, mg, is pulling down from the center of the ladder, and the force on the wall has only one component. It's pushing sideways on the ladder. Meanwhile, the force from the floor has two components. One pushing up on the ladder, equal and opposite to the force of gravity, and one pushing on the ladder toward the wall, equal and opposite to the force from the wall. Let's talk about the force from the wall first. We don't know how strong it is, but we can figure that out by thinking about the torques acting on the ladder. The ladder isn't rotating, so any torques acting on it have to add up to 0. And we know from our previous lessons that torque is caused by a force applied at a distance from an axis. So if we choose the point where the ladder touches the floor as our axis, we can see that there are two forces applying a torque to the ladder. In this case, the ladder is leaning to the right to meet the wall, so the force of gravity is applying a clockwise torque, and the force from the wall is applying a counterclockwise torque. And we know that both of those torques equal each other because the net torque on the ladder is 0. The torque from gravity is equal to the ladder's weight times the perpendicular distance from our axis to the center of the ladder, and that's 147 Newton meters, meaning that the torque from the wall is also 147 Newton meters in the opposite direction. Divide that by the vertical distance from where the ladder hits the wall to our axis of rotation, and we get 36.8 newtons. The force from the wall on the ladder. That's half of the problem done. But what about the force on the ladder from the floor? Like we said, there are two components of the force from the floor, horizontal and vertical. The horizontal component will be equal to the force from the wall, so 36.8 newtons, and the vertical component will be equal to the ladder's weight, so 98 newtons. We've already talked about how to find the total magnitude of a force from its components. You square the components, add the results, then take the square root of that number, meaning that the total force from the floor on the ladder is 105 newtons. So once you know that an object's in equilibrium, you can use that fact to find the forces and the torques acting on it. That's important because those forces can affect the object's shape and maybe even break it. That's why one of the main questions that engineers consider is, when I apply a force to a thing, what will happen to it? And generally, whatever happens will be one of these three main things. First, you can apply just enough force that the object will either stretch or compress, but still spring back. In that case, the force is in a range known as the material's elastic zone. But if you apply a little too much force, the object might become permanently deformed, meaning that the force has reached what's called the plastic zone. And apply way too much force and you'll get to the breaking point, otherwise known as fracture. Ideally, engineers want to make sure that the objects they use to build things like support beams stay within the range of option number 1, the elastic zone. Often they'll also want to know how an object's shape changes based on the amount of force that's being applied to it, and the amount that an object stretches or compresses depends on a few different factors. First, there's the original length of the object. The longer it is, the more it will stretch or compress. The strength of the applied force also matters. More force means more stretching or compressing. Then there's the area of a cross-section of this object. Basically, the thicker it is, the less it will stretch or compress. Finally, there's the type of material itself. Wood, steel, aluminium, granite, they're all going to have different amounts of elasticity. That's why engineers use something called Young's modulus. It's a number represented by a capital E that tells you how hard it is to stretch or compress a given material based on that material's stiffness. The higher Young's modulus is for a certain material, the less elastic it is. And all of these factors combine into one equation. It might look kind of messy, but this equation is just saying that the change in length of something that's being stretched or compressed depends on its original length, the force you apply, its cross-sectional area, and Young's modulus. And we can use this equation to help define a couple of terms that engineers use a lot: stress and strain. Now, those aren't the same feelings you get the night before a huge exam. Instead, stress is the force on an object divided by its cross-sectional area, basically that F/A term, and strain is the object's change in length divided by its original length. This equation and Young's modulus apply for two types of stress: tensile stress, which stretches objects out, and compressive stress, which compresses them. But sometimes the forces you apply to objects aren't just compressing or stretching. For example, you could also apply what's known as shear stress. Maybe you've done this before. Say there's a really thick book laying on a table, say Game of Thrones or a big dictionary. If you push the top of the book parallel to the table, the pages will sort of slide over each other. Where before rectangular looking book. Now you have more of a parallelogram. The sliding happens because you're applying a force to the top of the book, while the table applies an equal and opposite force to the bottom. That's shear stress. And the way an object forms under shear stress depends on the same kinds of factors that are involved when you compress or stretch something. Like if the original length were longer, meaning you have a thicker, taller book, that would mean more sliding, more force, or sliding. More area perpendicular to the force, in other words, a book with bigger pages, less sliding. And then there's the inherent slidiness of the material that the object's made of, which we call the shear modulus. Just like Young's modulus, the shear modulus is different for every material and is just a number represented by capital G. The higher its shear modulus, the less the object will deform. Put all those factors together and you get an equation that should look very familiar. It's just like the equation we had before for stretching and compressing. The only differences are that the original length, area, and change in length represent different parts of the object and that we use a different modulus. So we have one last type of shape change to consider. Shrinking. This is what happens if you apply force to all parts of an object at once, say by putting it in water. The same factors affect the shape change here too. The more volume the object originally had, the more it will shrink. In other words, the more its volume will change. When we're talking about something submerged in a fluid, we give a different name to the force divided by area. And instead of stress, we call it pressure. And the more pressure you apply to an object, the more it will shrink. Finally, some materials are more resistant to changes in volume, and that stiffness is measured by the bulk modulus, represented by capital B. Combined, these factors form an equation you can use to predict how much an object will shrink. So you now know the three main ways that forces affect an object's shape: changing its length through tensile and compressive stress, deforming it through shear stress, and changing its volume through pressure. And hopefully now you also have a better understanding of all the thought that goes into making sure buildings and bridges stay up. Today you learned that the net force and torque on an object in equilibrium must equal 0. And you saw how you can use that fact to calculate individual forces and torques. We also talked about the way objects deform under tensile, compressive, and shear stress, as well as pressure. Crash Course of Physics is produced in association with PBS Digital Studios.
Okay. 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 Dengar balik apa saya tukar tadi short pakai earphone. Okay. So let's give you some overview on what we're gonna go through all this semester. But some, of course, there's a few things that is perhaps something that beyond the scope of our course. For example, elastic, plastic, fractures. So this is something that you're gonna explore later in your time during your time in mechanical department. Tapi let's give you some overview on how you're gonna use the static, dynamics, and whatnot in terms of the to master this mechanics of the material. Okay, so this is two basics on the nama pun basic quantity, very fundamental concept. So this is just to refresh you, nothing to worry too much about this. So it's about the length, right? The position of the point in space, or describe the physical system. Time, T, right? So it's a succession of events or history, time history. So mass, kilogram, right? Property of matter, can compare the action of one body with that another. And then of course, we're looking a lot of the force, push and pull. Exerted by one body to another. Right. So we're looking on particle. That's the term that we're going to use. Which is the particle ni dia ada mass, but kita ignore the size. Right? Size here doesn't matter. So but dia ada mass. Right? Dia ada number. Geometry of the body will not be involved in the analysis. So you are not talking about the shape, the body. So for example, it doesn't matter whether it's a cubic, whether it's a sphere, it doesn't matter. So we consider only on one dot point. One dot point, the particle with a mass, 10 kilogram. Right? So that is a mass only matter, but not size. Okay, bila we're talking about rigid body, it's a combination of the numbers of the particle which are fixed, remain at the fixed distance from one to another, both and before applying the load. Sebab kita rigid body, rigid, there's no changing in the shape. Hence, the particle here will remain at the fixed distance before and also after applying the load. So is the particle, the position of the particle to remain at that particular location. Sebab we are talking about tak changing shape. So rigid body ni does not change the shape even after you apply a load. Concentrated force, itulah ada satu point. So the loading is only acting at one particular or one specific point. Okay, so dia dekat particular. So this is what we call concentrated loading. Okay. First law. Ni saya cakap tadi First law, kita ada 3. Newton's law of motion. So this first law ni is what we call a particle originally at rest or moving in a straight line with constant velocity. Bila kita kata constant velocity tu, V tu ada something value lah. Setelah ada A value. Sorry, kita pakai B lah, nanti confuse. B value. Tapi sebab the constant velocity, there's no acceleration. So A is equal to 0. Right? So it's constant velocity, no acceleration. We remain in this state provided the particle is not subjected to an unbalanced force. Meaning that any forces now acting into the particle as at the equilibrium state. Alright, so particle originally at rest ataupun originally moving in the straight line with a constant velocity V. Okay, and then there is several forces acting, F1, F2, F3 acting on the particle. Okay, as long as the forces acting on the particle at equilibrium, right? So at equilibrium, so they will remain in this particular state throughout. They can remain throughout. Yeah. So ni saya nak faham balik. I know you've been go through this form 4, form 5, foundation. So I just refresh you balik. I repeat. So particle originally at rest, bila rest ni V equal to 0. V equal to 0, of course A equal to 0. That is rest. Okay. And moving this straight line with constant velocity. So V ni ada value. V is not 0, but A is still 0. And then you have, kalau dalam contoh ni, you have three external forces or external loading. Alright, but these 3 external loading ni is still in equilibrium. Kalau kita tak boleh balancekan dia, meaning that if you have another force, maybe F3, F4, right, that kacau the balancing tu system, dia tak no longer in equilibrium, benda ni not happen. Tapi in this our case, F1, F2, F3, dia dalam equilibrium. So when it's in equilibrium, dia balanced. Dia balanced. So apa Newton first law kata? So this particle ni akan remain in this particular state throughout. Yeah? Faham eh? I think this is a very simple one. Second law. Second law ni kita pakai ni. Senang. F equal to MA. Yang ini tadi ni tak silap total force equal to 0. Sama juga lah, dia remain the constant. Remain. Yang ini F equal to 0. Again, we are talking here about the particle, this is particle, the blue one, upon by an unbalanced force, experience an acceleration, okay, ada acceleration, right, to the force and in the same direction of the force. So kita ada force dekat sini, right? So kita particle ni ada mass m, right, and then we have the acceleration. So second law kata particle acted upon by unbalanced, so force ni is unbalanced. The particle ni akan experience the acceleration, right? So when we have a particle and then kita push particle, katalah kita ada bola ataupun somehow in your table currently ada cup, ada cawan, right? So tak apa, you tepis je cawan tu. You tepis cawan tu pergi mana? Mesti cawan tu jatuh. Okay, so tepisan you tu is the unbalanced force. Right, tepisan tu is your unbalanced force. You ketis cawan tu, alright. And then dia particle tu, which is the cawan tu, right, will experience from the static condition, from the zero condition, right, and then to some sudden motion. With that sudden motion, cawan tu jatuh ke, cawan tu terbalik atas meja ke, lepas tu air tumpah ke, lepas tu mak marah ke, after that. So that is what we call accelerated motion. Ketis, cawan jatuh, that is motion, right? Accelerated motion, a sudden motion of that particular cup, cawan tu. Okay. So F equal to ma. So this is no longer static. So F ni and A ni is no longer equal to 0. That is the second law. F equal to ma. Okay, boleh second law. Third law. Third law ni yang bila yang tadi I message dalam yang I put the message in the group tu, bila while we are watching the video, tu is about the reaction force. Okay, the reaction force. So every force acting on a particle, so ini kita katalah this is F acting on the particle, this is maybe Fr, right? So force acting on a particle A, right? So force ni daripada A, so force of A acting on the particle B, right? Daripada F ni ada mass, right? Mass A, and then this is mass B, right? So this is Fr ataupun Fb. Okay, this is F flight ataupun Fa. Okay, so kita ada force from the particle A with mass, itu ada mass. So kita ada force from A acting on the another particle, which is B, right? Which has the mass as well. Right. So B ni mungkin at the initial condition V remain 0. So it's a static condition, V equal to 0. So dia tak bergerak. Tapi kita ada bola. Ataupun kalau you all main snooker, saya dulu masa belajar suruh main snooker. Okay. So you ada snooker. Itulah, imagine this is snooker ball. Ada snooker ball. This is white ball. So this is maybe red color ball. Alright. So you snook. You snook A and then you push into B. Alright, B tu static, and then bila A tu of course lah static, lepas tu dia ada motion. Dia bergerak towards the bola B. Alright, B tu initialnya static. And then pop, dia engage to ball B or the hit ball B. There will be a reaction force which is acting perpendicular from the FA. So FB ni dia akan acting perpendicular ataupun in the opposite direction. Sorry, not perpendicular. Sorry. It's in the opposite direction from the force A tadi. So FB dan FA is in the opposite direction. So we can, if bola snooker tadi push A dengan B, and then bila dah engage, dah hit, A hit B, B akan stop, A akan stop. So meaning that there is in the equilibrium there, right? So we can say FA is equal to minus FB. Okay. Itu satu one condition. Ataupun bila you hit bola A, bola B, they are moving in the same velocity. Boleh juga. Ball A and ball B moving in the same velocity. VA equal to VB. Mungkin constant. So A sini ada. So A kat sini equal to 0. Still in equilibrium. The static equilibrium. Tapi kalau B going faster, right, this is ada acceleration. A going slowing down, decreasing, katalah A, acceleration kat A maybe is negative, decelerate. And then AB is maybe positive, accelerating. So this is no longer static. So ni you belajar dynamic nantilah. Right? So it's no longer static. So senang je kita nanya. Kita paksikan pada A, acceleration. Okay, clear? So I put in this a very simple way so that everybody can understand it. Okay, another satu lagi Newton law. Newton law. Okay, this is what we call gravitational attraction. Gravitational attraction ni is you imagine magnet lah senang. Magnet particle. So kita ada magnet A, kita ada magnet B. Particle A, particle B. Right? So you putting in some distance. Some distance kat sini R. Okay? Of course, dia ada mass, dia ada mass. So M1, M2. Right? So this is M1 equal to MA. So this is M2 equal to MB. Alright. So bila ada particle in the same space of the body, katalah ini the whole space. Ini body. Right? Macam tadi kita bagi tahu, dalam body dia ada banyak partikel-partikel lain. So kita ambil contoh partikel A dan partikel B saja. Tak nak complicatedkan. Okay. So ada two partikel A dan B dalam satu space. Space ni representing body. Okay, from distance between A dengan B kita panggil R. That's distance between B. So particle A dan particle B, or particle 1 or particle B, particle 2, that have their own masses. So hence is M1 and M2. And then this is what we call constant or pemalah, constant value, which is equal to this universal constant of the gravitational. So Newton kata this is what we call gravitational attraction between one point to another point, between Rx and boyfriend. Right? So there ada what we call gravitational effect between one to another. Right? So this is constant is given to this value. So because of that, there will be a force. There will be a force acting between the two particles, what we call gravitational force. There will be the force acting between the particles. Alright? So force tu ada. That's what we call, kalau you belajar kimia ke apa ke, covalent bond, all the bonds of the particle within one body, between one interaction to another interaction, that is something what we call gravitational force of the particle within the body. Right? So of course, some of them are very low, some of them are big. Depend on the masses. Ni masses ni, M1 multiplied by M2, between of the masses. And then also depend on R. Kalau R lagi jauh, meaning that particle 1 and particle 2, the jarak dia jauh, distant, bit far. So the force is less. But if close, then you have this higher force value acting between the particle. Okay. Boleh ya? That three laws of Newton. Okay, weight ni senang je. Weight, kalau you ukur berat badan, itulah weight. So weight is mass in selalunya kilogram ke gram, that is mass. multiply by G. So you have weight. Weight is in Newton. Okay. Acting here. At the center of the particle or center of the rigid body, selalunya dia at the center So ini very center of the gravity CG. So they're acting on the central, right? Pointing to the gravitational punya G punya direction. So usually G is pointing downward, right? So that is basically your weight. Yeah. Okay. Unit of measurement. So these three are basically the base units. So mass, kilogram, length, meter, times second. Right. So this is basic unit, right? Basic quantity, sum of the basic quantity, sum of the basic unit. So kita pakai SI. So that will be the number. Derived unit, for example, force. Force tadi kita tahu kilogram. Sorry. Force tadi F equal to MA, basically, yeah. So MA is kilogram, K is basically meter per second square, right? So hence this is the value. Meaning that 1 Newton, unit the Newton, equal to Newton. So either you can use this value or you can use this value, right? So 1 Newton equal a force. One force required to give 1 kilogram of the mass acceleration of 1 meter per second square. So 1 kilogram multiplied by 1 acceleration, 1 acceleration, will give 1 meter. And then tadi weight, so it's a mass, kilogram, and then gravity also acceleration, and s square. So you'll get the same thing. Right, so Newton is kilogram per okay, alright. Salah. Bosan aja subjek unit ni. Kau mesti bosan ni kan. So, okay. Ni dah cerita. Don't worry about it lah. We never been using this. We are not in US. We are not in British. We are in Malaysia. So, Malaysia using this. Okay. Ini yang saya kata ni. Kalau in case you are forgetting about this prefix. Right? Prefix and exponential form. Okay. Giga 10 to the power 9. Giga, mega 10 to the power 6, kilo 10 to the power 3, milli 10 to the power minus 3, micro 10 to the power minus 6, nano 10 to the power minus 9. Okay, so this is SI unit yang kita pakai, giga, mega, kilo, milli, micro and nano. Right? So ada lagi kalau nak tambah pico, Pikachu 10 to the power 12. Right. Sini yang kita akan banyak lagi dah kena pakai. Right. Kalau minus side, yang minus tak ada. Minus ni ada. Right. So mostly kita akan pakai mungkin giga, mega ni selalu. Kalau E selalunya dalam Pascal, so it's 10 to the power of 9, sometimes go only 10 to the power of 6 Pascal. So rather than kita tulis as this exponential form, kita tulis E yang modulus tadi in maybe gigapascal. Sigma, yield stress in megapascal. Typical number that we are writing down. Right, so remember this. Sometimes silly mistake been done by a student. Right, not even kadang-kadang master PhD student pun buat silly mistake macam ni. So bila you put the calculation, they don't consider this giga, mega, kilo ni. Right, so hence your final answer will be wrong. Okay, so what we mean by dimensional homogeneity. Each term must be expressed in the same unit. Maknanya, kalau you using SI unit, basics, so use SI unit. For example, I'll give you an example. If you are calculating F equal to MA, right? But you know basic units for mass is kilogram. This is meter per second square. But sometimes the question is a little bit tricky rather than giving the exact values in this kilogram or meter. Sometimes the bagi unit maybe L in millimeter. So you need to be consistent in the calculation. If you are using ataupun M in gram, for example, right? Katalah 100 gram. So you need to be consistent in the calculation. So what you're gonna do is basically we're changing that basic parameter into the standard ataupun consistently in the SI unit. For example, if you want to use this formula, which is using kilogram, meter, and second. So you basically need to change this into meter, and then here changing this into kilo. Right? 10^2, sorry. 1 gram, 1000, sorry, 10^3. Right? So changing that consistently into the calculation that we want to do. Kalau T given in hours, so you need to change that into second. Berapa? In second. Okay, any digit including zero, but it's not used to specify location. Provided it is not used to specify the location of the decimal point of the number. Yeah, sometimes zero, I don't know what's that mean. Any significant figure, any digit, including zero, provided is not used to specify the location of the decimal point of the number. Yeah, I mean, this is basic. Kalau that zero has some value, then okay. But then after decimal point, maybe 23.00. So this is no significant figures, since that can be ignored. Right, rounding off number, and then correction rounding off. Okay lah. So it depends on the accuracy lah. But this is not a major concern here. That's maybe used later, but not here. Okay. Tak apalah. This is your guideline. Yeah.
So,
Ah.
your battery almost dying.
Okay. I'll cari. Okay. This one. So okay lah. I mean, along the way though, this is the general procedure that we go through. So usually so you need to read the question and things. So this is free body diagram lah, basically in our case. So mostly we are using free body diagram, and then we looking on the equation of the equilibrium. Selalunya kita tengok Fx equal to 0, Fy equal to 0. So resolve into that particular axis or not. And after that we solve the equation. Tak perlu hafal prosedur ni, but along the way unconsciously when we go through the example, the questions, the quizzes or tutorial, so unconsciously we're gonna follow this step by step procedure. So unconsciously, that kalau you rajin selalu buat, unconsciously they will go through that lah. So typically we start with the free body diagram. Once you know a free body diagram, once you draw the diagram, then yang the rest ni dia akan coming together nicely automatically. Alright. Habis dah untuk slide chapter 1. Sebenarnya hanya habis dah untuk chapter 1. Okay, what are we gonna do? Take a break?
Apa?
Break dulu lah.
Yeah,
So,
take a break.
5 minutes each. 5-ish minute break, and then I'll charge my laptop, and then the come back break 5 minit each. Kita come back around, kita buat 8 minit lah. 8 minit. So we come back at 3:10. Okay, so as layan dulu. Okay, tadi you minta ni am I right? You minta this.
Yes.
Okay, boleh I share dalam you learn.
Okay, sir.
Tapi
Terima kasih
betul,
banyak, sir.
ini continuous assessment, assignment, quizzes. Ikut ni lah je lah, senang, tak payah nak complicated. Yang penting you belajar rajin-rajin. Pass the subject. So 10 to 50, 60% here. And then extended assignment 40. Assignment quiz banyaknya. 5 and 5 bagi markah 10 je. Satu assignment atau satu quiz 1% saja markah. Kesiannya you all. So you all nak banyak soalan ke? Nak soalan yang senang-senang? Sebab kalau ada 5 ya, this is all lah. 5 assignment, 5 quizzes.
Nak yang paling senang, sir.
Tapi you all copy paste je, tiru sama kawan-kawan. Tahu, I belajar student juga, bukan student yang rajin, yang baik. Student jahat juga, that's why I tak ada rambut, botak. So, yang ini, okay lah, hantar group. Assignment by group, you ada 60, dalam list ni you ada lebih kurang participant. You ada lebih kurang 60, 64. 64 ni kena minus Dr. William. Ada rajin yang masuk, William Pau. Masuk dalam ni juga. So, semua student. Tapi William Pau dia rajin masuk dalam ni. Dia nak jadi spy you all lah ni. Belajar ke tak belajar. Okay, so 64 minus 2. So ada 62. Okay, maximum group 5 too much lah. 5 is the maximum number. 3 is the minimum number. Tapi semua jawapan sama je nanti. Kan? Mestinya. So tak apa. So sebab 1% je. Tapi jangan tak hantar. You all kena hantar. Tidak rugi 10%. Ini macam markah free lah untuk you all. Kita bagi 1 soalan, 2 soalan per quizzes, per assignment. You submit. Ini 10% markah free. And then test. Test ni serius lah, exam. Serius sikit lah. Kan? So 50. And then extended assignment 40%. Okay. So ini I boleh share. Tapi you just ignore the name je lah. Sebab ni yang lama punya. So abaikan je lah. Nama ni. Nanti anyhow. Nama ni pun kalau I ubah pun ubah nama je. So why don't kita buat benda yang lebih produktif rather than just copy and paste tukar nama. So I lagi jahat kan. I tak tukar nama. Walaupun I copy paste I tak tukar nama langsung. So I hantar dalam mana Where is it tadi? Hilang lah. Tua ni nak kena belajar ni. My course. Ketik. So assignment blah 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 blah. File. Okay, so I masuk kat sini. This is what we call whatever is CMF static. Buat sekarang nanti I lupa. Okay. So kalau you all nak tahu, sekarang ni I berada di Kuantan. So ada kerja dekat Gebeng di Petronas Gebeng. So I basically macam consultant Petronas. So sekarang ni esok ada nak masuk site Petronas, ada teknologi what we call ADAPT. So teknologi ni kita deploy dekat site. So teknologi ni kita develop together. So collaboratively dengan UTP, GTS, Petronas. Petronas TVE dan juga GTS. So that's one thing lah, kita buat the technology development dekat Petronas plant. Bulan 11 dekat Bintulu. So nanti I'll be teaching you live from the Bintulu. So hari ni live from the Kuantan Timur Bay. Okay, mana tadi? Okay, why not kita do something? Kita do something. So you asyik dengar cakap aja kan? So I need you to do something for me. Let's go a very simple question. Okay, soalan yang satu dan soalan dua ni you boleh buat. A very quick one. Simple one. Question number 1. Kita terus buatlah, ini soalan tutorial. Kita terus buatlah untuk chapter 1 ni. Okay, so what I have here is question number 1A. Okay, so kita ada this 354 milligram, right, multiply by 45 kiloliter, divide by 0.056 kilonewton. Okay, so kita ada dalam ni miligram, kita ada dalam kilo, kita dalam kilonewton. Okay, you change that into some value, a basic in kilogram, multiply by meter, divide by newton. Okay, you buat sekejap. Maybe 5 minutes, 3 minutes even. A quick calculation. And then post your answer in the chat. Okay, dah siap, put in the chat. Tak dapat, raise your hand. Relax-relax je lah, hari Isnin, kelas pertama, pelayan bebelan saya. Okay, dah belum? Hai, saya dapat yang lain. Hai, jawapan lain-lain. Apa dia? Serat. Betul lah. Anggur tu. Dia 354. 354 milli. Right. So kita buat milli lah satu-satu. Kita start by start. Miligram. So you dapat dalam gram. Right. So multiply by kilo. Multiply by kilo, 45 kilo. Right. 10 to power of 3 dapat meter. Ada yang dah betul. So, you divide by 0.0356 kilo. Right, ini dalam meter. Okay, tapi yang ini you ada is dalam kilo. Right, kilogram. So, ada 10 to power of 3 kilo. So, you dapat 0.447. Nanti I share lah jawapan dalam Ulen. Tengah step dia. Okay, so Daniel betul, Afzal betul. Syakir ni hampir betul saja. Sikit lagi. Dia 0.447. Okay. Second chance. Pada edit. Okay. Right. So next one kita buat soalan nombor 2 tu. Buat soalan nombor 2. B. Buat soalan B pula. Nanti I bagi jangan rusih. Dia punya step-step nanti I share dalam Ulen dia punya solution dia. B, kita ada mega. Right, so 0.00453 megagram. So 10 to power of 6. Tapi nanti you kena tukar balik kepada kilogram. So right, so you ada 10 to power of 3 lah. Okay, 10 to power of 6 mega. Tapi you nak kilogram. Jawapan B ni nak kena put dalam kilogram times second. Sorry, second. Okay. So, and then you multiply dengan 201 dalam mili. Okay, cepat. The mega. So, ini dalam kilogram siap-siap. So, you ada mega 10 to power of 6. And then ada orang telefon. Sekejap. You go on. I nak kena pick up phone ni. Okey. Okey. Senang je soalan kan. Semua dah boleh jawab. Okey, last one. Satu lagi. Dan kita buat ni pula soalan number 2. Number 2, you're using that question, the equation F equal to jawapan dia ikut ni tadi betul lah. Soalan number 2, okey betul. 0.911 kilogram second. Number C, this right. Yanwei correct. Afza correct. Right. So is 1.88 lebih kurang 1.88 10 to the power of 10 Newton meter. Okay. So kita tengok last one. Lepas tu hari ni tak bagi lah soalan. So kita ambil soalan number 2. Number 2 kita pakai ni. F equal to G constant. This is what we call the gravitational extraction of the Newton law. Mana tadi? Nota tadi. Right. So F equal to G M1 M2 divided by R. Right, R square. Sorry, R square. All right. So what we have here, M1 8 kilonewton, 8 kilogram. Sorry, M2 kita ada 12 kilogram. Right. So R is 800 millimeter apart. All right. So you have 0.8 square. So this is R. Okay, so R square, square kan dia. G is this one 66.73 10 to power of minus 12. Unit jangan lupa meter cube divided by kilogram second square. Okay. So G adalah 66.75 or 73 10 to the power of minus 12. Right, we need the meter cubic kilogram second square. Okay, so you dapatkan dia panggil what we call determine the force of the gravity or gravitational extraction force between these two particles. So what we got? Okay. Senang easy peasy. Dapat 10 nanonewton ataupun 1.0 something 0001 10 to the power of minus 8 Newton. Okay, Afzal, correct? Good. Brilliant. Compare this result with the weight of the each particle. Apa weight of the particle? M1 tadi 8 kg, jarak dengan 9.81. Itu dapat 12 times 9.81. So you got here lebih kurang 78.5 Newton. And then you have 118 Newton. So you compare. Kalau you tengokkan kat sini tadi gravitational force F between particle tadi, gravitational F is 1.10 to the power of minus 8 Newton. So you compare weight itself with 178. This one is very, very insignificant. Very, very low. Can be ignored. Right? W2 pun you dapat 118 Newton. So F ataupun what we call gravitational force between these two particles is negligible. So penat dah kira tapi it's a negligible. So we don't really include that into our calculation because it is very, very small, very, very negligible. Boleh? Any question? Okay, cukup kot hari ni. 1 hour and half kita cover. Agak nak pergi question number chapter 2. Not yet. Hari ni kalau kita warm up, kita baru warm up our brain after first day of the semester. We have a lot of time to see each other again. So this is we cover chapter 1. So chapter 2 kita akan start ni lah. Kita akan start chapter 2. Skala and vector, vector operational, Charterson vector, position vector, coplanar force, force vector, dot product. So next week chapter 2. Kan nak ada lagi session this week?
I think this week enough dulu.
Okay. Boleh je. No worry. Don't worry. I'm sure. Okay, so kita this week baru nak warm up kan. Next week kita start ni lah. Kita little bit more serious. Kita punya effort and seriousness tu will be more compared to this week. My ground rule macam tu lah. So along the way, I bagi lecture. At the same time, I bagi question. We do it together. And then the nice orang kata apa solution tu nanti I put in the ULearn. I put in the ULearn lah. So ULearn nanti you refer. Ada satu ni dia panggil apa? I hate these things lah. Dia panggil what we call learning satisfaction poll. Saya tadi ada bergaduh lah dalam department. Because this is nothing to do with our teaching performance. It's about platform. So faham lah you about online platform kadang-kadang the connectivity is there, the issue. That's why I don't depend solely on one platform. Kalau ada you masalah, I share you my number, I share you my email address. Give me shout anything. So kalau you nak jawab, you jawab lah. I put in the ULearn. I open this at 4 rasanya, at 4 PM. So just a quick click while you are checking the notes. Kejap lagi I terus akan masukkan notes for and then the question study dan the solution. And then also I akan masukkan also for our next class dalam topik tu. Kita akan put the notes in the topic tu, lecture notes. So while you're browsing that, you learn ni. So just a quick one and then you just click lah whatever and then give your feedback. Okay. Well, okay. If this is not much to ask from you. Okay. Any question? Any last question before we end? Hopefully you enjoy my class. Sorry lah, after 3 years of not teaching, and then this is the first day of teaching online. So last saya ngajar masa zaman before COVID, BC before COVID. So this is the first time I've been teaching you guys online. So hopefully, just what I want is give some slack. If you are think I need to further improve, give me a shout personally. Boleh email, boleh WhatsApp. So just give me a shout. So I can further improve for us, to benefit us. Senang, you all nak belajar sebab I tak nak lah my fail. Walaupun I cakap tadi ramai akan fail, tapi deep down I tak nak, I nak you all pass semua. Right? So, okay? Itu dan sama je. Okay, I'll forget the Najiha, I'll forget the tutorial tadi dalam you learn, and then the some of the solution yang kita buat tadi, question 1 and question 2. Yeah, we'll get more exercise further down the line. There's more difficult question down the line. So kita solve together. Okay, nak buat WhatsApp group, it's up to you. WhatsApp group tu up to you, tapi macam tak perlu je kot. Ikutlah, up to you. Saya follow through je. Kan senanglah sikit announcement semua. Up to you. Tapi my main platform will be Ulearn. Okay, will be Ulearn. Kalau you tak nak masukkan dalam WhatsApp group pun, untuk you all je pun, it's okay, no problem. Tapi my main is Ulearn. Alright. Anything else? Kalau tak ada, 1, 2, 3. Tadi nak jogging tepi laut. Sorry. I dah full vaksin. So boleh jogging tepi laut. Sorry You all take care. Jaga diri elok. We'll meet you again 2 PM next week. Anything I'll give the link nanti I bagi dalam Ulearn. Any burning question before that, let me know. Alright, take care. Stay safe. Belajar rajin. Alright, study hard. Study smart. Not hard, study smart. Alright, thank you. Bye. Bye.
Thank you so much, sir.
Thank you.